Hey class, so today we're going over area, the perimeter or circumference, and the trig function questions from our test. And I'm going to start off with the area question. So the area question on the original test said that there was an area of 2,000 square feet that is covered by a rotating sprinkler system. If the sprinkler is 200 feet long, how far has it rotated? A in radians, B in degrees. So our area formula is going to be A is equal to 1/2 r squared times theta. Okay, and units wise, we can see that this 2,000 squared feet is going to be plugged into our area, and our 200 feet is going to be plugged into our radius. So you can do this two ways. You can plug it in first and then solve for theta, or you can rewrite the formula by doing some algebra. I like to rewrite the formula. So basically we're just multiplying by 2 and dividing by r squared. So we get 2a over r squared is equal to theta. Because again, we're looking for rotation. And anytime we're looking for rotation, we're solving for theta. So then when we take this left side of the equation, 2a over r squared, and plug in our values, we get 2 times 2,000 divided by 200 squared. We can just plug this into our calculator and we get 1/10 rad or 0.1 rad. Either way, this works. So this is going to be our answer in radians. I'll just circle the 0.1 rad. That's going to be our answer to part A. So then we take that 0.1 and we multiply that by our factor of 180 over pi. And this is to transfer it from radians to degrees. So this is going to equal 18 over pi, which is approximately 5.73 degrees. So just a few important things that I want to point out, just some mistakes that I saw. When I give this feet measurement right here, tell you it's 200 feet long, don't assume that it's the diameter. If it was the diameter, I would have told you it was the diameter. Always assume that if there's no like specification in these problems, assume it's the radius. Otherwise, I would have said, the diameter of the sprinkler, so that way you would have known to divide it by 2. The second thing is make sure that you're doing the algebra correctly. You need to multiply by 2 and divide by r squared to get theta alone. I saw some subtracting and some weird multiplication, so make sure you do that correctly. And then the last part is that the theta that you solve for is in radians. It is a radian measure, so always keep that in mind. You do not have to add a pi to this. Don't add a just random pi to this because you're solving for the angle. When you're solving for the angle, you won't necessarily get a pi, even though it is a radian measure. Okay, so those are basically the mistakes that I saw and everything that I have to say about this problem. So let's move on. Okay, so here we have the arc length problem from the test, and there are two ways to solve this problem. I'll go through one of them, which is the longer, and then I'll highlight the way to solve it the second way. So if you remember, the arc length formula is going to be S is equal to theta r. But in my problem, I didn't give you either theta or r directly, but I gave you ways to solve for those. So the first thing that we can solve for is this r. So when we wanted to solve for r, I gave you that the circumference was 2 pi r. Let me rewrite this. 2 pi times r. And I gave you that the circumference was equal to 20 pi inches. So in order to solve for r, all you have to do is divide both sides by 2 pi. And then from that, you reach that r is equal to 10 inches. So that's how you solve for your first variable. The second variable is going to be your theta. And in this one, you were given that you have 8 slices in your pizza. The entire radian measure of going around the pizza, one full rotation, is 2 pi. If you have 8 slices, that means that this 2 pi is divided by 8, and each pizza slice covers a total of pi over 4 radians. And that's how you find your second variable. So once you get both of these, you can type that into the arc length formula. So you have 10, you have pi over 4 times 10. And this gives you that S is equal to 5 pi over 2, which is approximately 7.85 inches. Okay. The shorter way of doing this is by remembering that the circumference is the entire edge, like the entire crust of this pizza in this problem. And the slice is just a portion of that circumference, right? So we can, instead of dividing our theta by 8, or 2 pi by 8, we can just divide our entire circumference by 8. So we can take 20 pi inches and divide that by 8. And through simplification, we can see that this also equals 5 pi over 2, which gives you that S is approximately 7.85 inches. So both of these are equally valid, just depended on which way you saw it. So the main takeaways I want to talk about in this is that you have to remember your theta in your pizza slice rotation is just a segment of the entire rotation around the pizza. It's just part of that rotation. And similarly, your S, your arc length, is also just a piece of this full crust, which is just the circumference. And so this was all about just seeing that both of these measurements are just pieces of some whole that in theta's case you can get for every pizza, but in the arc length case you can only get when you're given the circumference. So let's move on. Okay, so here we have two problems on trig functions, and I'll start with the one on the left, sine of pi over 3. So the main thing to look for when you're doing trig functions is, what is the angle? Is this angle pi over 3, pi over 4, or pi over 6? Because we know these special right triangles for these three angles. So that means we can evaluate their sine, cosine, tangent, whatever function of these angles with no problem. So for the pi over 3 angle, we know that if we look at our special right triangle with pi over 3, that angle will be right here. Here's our 90 degrees. And in this triangle, we had the side length 2 for the hypotenuse, square root 3 for the height, and just 1 for the base. So sine is opposite over hypotenuse, which means that sine pi over 3 is simply square root 3 over 2. So again, look for the theta. If it is pi over 3, pi over 4, or pi over 6, just use your SOHCAHTOA rules and your special right triangle. side lengths. So that's the answer for that one. And then on the right, we have angles that are not our special right triangles. So these are just thetas. Whenever you see either an angle that's not a special right triangle or an angle that's left as theta, that should tell you, okay, I have to use my identities in order to just simplify this. I won't be able to necessarily evaluate it to some number, though sometimes you can. So in this example, the first identity that you have to use is the cofunction identity for sine theta. So the cofunction identity will tell you that sine of pi over 2 or 90, I'll just write it as 90 since we have this 90 in the problem. Sine of 90 degrees minus theta is equal to cosine of theta. So one thing that I want to say and emphasize is you only alter one of these trig functions at a time when you're trying to simplify them. Don't try to rewrite sine and tangent in this problem at the same time, because you might make a mistake, you might make it more complicated, or you might just miss a substitution. But okay, now that I've said that, all we're doing here is we're replacing this sine 90 minus theta with cosine theta. And we're rewriting our problem cosine theta times tan theta. So the second identity we use here is our quotient identity. And this quotient identity tells us that tan theta is equal to sine theta over cosine theta. And again, all we're going to do is plug in this sine theta over cosine theta for our tangent theta. So now we have cosine theta times times sine theta over cosine theta. And whenever you have trig functions like this right next to each other in a problem, this is just a multiplication. So what we have really is cosine times sine over cosine. So these cosines will cancel out through division, and we're just simply left with sine theta. We can't simplify this anymore using our identities, so our answer is simply sine theta. Yeah, so that's it. That is the area, the arc length, and the trig function problems from the test. I hope this helped you guys out, and I'll see you next time.